my friend, happy to see you here. Welcome back to my channel, Hi Mathematics. Today we have a great, quick and relaxing algebra question. We know that the sum a plus b equal to 16 and the product a times b equal to 24. We need to solve this question for a and b, so write your solution in the comments below, write your thoughts, write your notes, and then we will check our answer, so it will be really interesting. So first of all, we have two equations, and what is the main method? How can we solve this type of question? First of all, we can express from the first equation very easily, we can express our b. So let's start with that. So our b is equal to 16 minus a. 16 minus a. And right now, we have the same b in the second equation. So let's plug in, instead of this b, let's plug in 16 minus a. Let's do it. So we have a times 16 minus a equal to 24. And right now, if we look closely, we have only one variable, only our a. So let's simplify it and let's solve this equation for our a. So a times these parentheses, we have 16a minus a squared equal to 24. And it looks like on the first side, yeah? It looks like this is a quadratic equation. We have square, we have a, we have constant, but with one really interesting moment, we need to change this order. So minus a squared we write on the first position. On the second position, we have plus 16a, so plus 16a, and minus 24 equal to 0. And right now the final trick, my quick recommendation to multiply both sides by -1, because everyone prefers right here this first coefficient with the positive sign. We don't like this negative sign right here, so let's change to the opposite one, and we have a classic order of signs. So a squared minus 16a and plus 24. So we need to change all the signs to the opposite one. And just agree with me, we have a classic, a really great quadratic equation. So I hope you understand my solution until this moment. What we're going to do next, of course, we're going to solve this question using our method of coefficients. So our a equal to, let's write it right here, our a equal to 1, our b equal to minus 16, and our c equal to 24. So we know everything, and right now let's solve it for discriminant real quick, okay? Let's solve it for discriminant. So d equal to b squared minus 4ac. So let's plug in everything. So b squared minus 16 squared minus 4 times 1 times 24. So let's simplify it. Let's solve this for discriminant. So we have minus 16 squared, we have 256 minus 4 times 24 equal to 96 equal to 160. So this is our discriminant. Discriminant is greater than 0, so it implies that right here we have two real roots, and it's also really great. So we have two pairs of solution. And right now let's solve it for a first and a second. We solve it for discriminant, we have it, and right now let's solve for a first and a second. So let's find exactly our root. And this is our all-known formula, minus b plus minus square root of discriminant and all over to a. So equal to minus b minus 16 plus minus square root of discriminant square root of 160 and all over to a, 2 times 1. Okay, this is our a first and a second. So let's simplify it real quick. So minus 16, we have 16 plus minus square root of 100 and 160. How can we express this? A lot of ways how can we do this, but maybe the best one is 16 times 10. Yeah, 16 times 10 all over. Of course, we can express it as 80 times 2 or 40 times 4, but why this expression is the best for us? Because square root of a product equal to product of square roots. So that's why we can split it. We can write it as square root of 16 times square root of 10. And right now, we can easily see this table case, because square root of 16 equal to 4. So we can write this one as 16 plus minus 4 square root of 10. 4 square root of 10 all over 2. This is our answer, but this is not like a final answer, because we can simplify this real quick. We can factor 2 from our numerator. We have 8 plus minus 2 square root of 10. 2 square root of 10 and all over 2. So we can cancel this 2 and this 2, and we have our final answer, 8 plus minus 2 square root of 10. So these are a first and a second. What are we going to do next? Of course, don't forget about the thing that we have plus minus. So we have two roots. A first, let's go with the plus sign, 8 plus 2 square root of 10, and with the negative sign, a second equal to 8 minus 2 square root of 10. Okay, 8 minus 2 square root of 10. And don't forget about b equal to 16 minus a. This is our expression from the beginning, 16 minus a. So that's why we need to find on the left side right here, we need to solve for b first, equal to 16 minus a first, and b second equal to 16 minus a second. So let's solve it, for example, for b first. So b first equal to 16 minus 8 plus 2 square root of 10. So b first equal to 16 minus 8 and minus 2 square root of 10. From here, b first equal to, right here we have 8, so 8 minus 2 square root of 10. 2 square root of 10. And we have the same thing right here. So b second equal to 16 minus a second. This one, 8 minus 2 square root of 10. So b second equal to 16 minus 8 and plus 2 square root of 10. So 16 minus 8 equal to 8. So b second equal to 8 plus 2 square root of 10. Okay, we have two pairs, a first, b first, a second, b second. So let's write it, and in the end we will check our roots. One really interesting moment, because we have two absolutely symmetrical pairs. So we have our answer. We have absolutely the same constant but different sign. Yeah, so we have 8 plus 2 square root of 10 and 8 minus 2 square root of 10. This is our first pair, and the second pair, 8 minus 2 square root of 10 and 8 plus 2 square root of 10. We have two pairs, first pair and the second one. And in the end, let's check real quick our pairs. We have sorry, we have two symmetrical pairs. So let's do it. Let's do our check, our proof. We need to the sum need to be equal to 16, and a product need to be equal to 24. Okay, what are we gonna do next? Right now, let's check real quick our sum, for example. But addition and multiplication are really great mathematical operations, because we can change positions. We can write a plus b and b plus a times b and b times a. So that's why we don't need to check both of these pairs, because our pairs are symmetrical. So that's why let's check, for example, these parentheses. So a plus b equal to 8 plus 2 square root of 10 plus 8 minus 2 square root of 10. So let's check it. So right here we can cancel this. 8 plus 8 equal to 16. Yeah, so a plus b equal to 16, and we have it. So a plus b equal to 16. And in the end, let's check real quick our multiplication. So a times b, we have two parentheses, so 8 plus 2 square root of 10 times 8 and minus 2 square root of 10. So let's check this multiplication. And I really hope you see that this is a classic school formula, because this is our a plus b, a minus b. And in terms of school knowledge, in terms of our algebra classes, this is equal to difference of square. This is our x square minus y square. So x plus y, x minus y. This is a difference of square. So x square minus y square. So we have 8 square minus y square, 2 square root of 10. We have square. So let's simplify this. So 8 square equal to 64 minus, right here we need to raise both elements to the power 2. So minus 2 square times square root of 10 square equal to, so we have 64 minus 2 square 4 times, right here we can cancel it. So 4 times 10 equal to 40. 64 minus 40 equal to 24. Yeah, and we have this 24 right here. So we can easily be proud of ourselves that we solved this question correctly. So here's our answer. I don't want to write this answer once more because I don't have enough space. We prove this answer. We prove that addition works perfectly, multiplication works perfectly, so it means that our roots are absolutely correct. There are a lot of ways how can you solve this type of questions. Of course, you can write your solution, write your thoughts in the comments below. Let's discuss a little bit about this type of question. So this is my way, maybe the classic method for most of students, because maybe there are a lot of students who are struggling with this type of question. So that's why I use this classic basic method of substitution. So we just express something and plug in into the second equation. Classic quadratic equation, discriminant, and in the end, basic algebraic things like checking our roots or expressing something or substituting something. You know, a lot of different things. So I really hope you understand it. But if you still have any question, write a question in the comments below. We have a really great community here. I'm going to say thank you for being here, for watching this type of content. So I really hope this video is helpful, and my main goal is to make math clear and understandable for everyone. So that's why I want to say thank you for being here, and I want to say see you in the next videos. Have a great day and take care of yourself.